in the introduction of cloud computing, we had already seen the cloud computing introduction, overview, technologies, hardware and software infrastructure, different cloud risk, cloud services and application, some regulatory issues and limitations. So, what are the standard definitions of cloud computing that we had seen are proposed by NIST and one of the famous paper on grid computing. So first definition explains that it is model of on-demand network access shared pool computing resources like networks, server, storage, application services that are being rapidly provisioned and having minimal effort for management for service provider interaction. So this is first definition that we had seen, and second one is extension of distributed computing. That it is cloud computing is a large scale distributed computing which needs abstraction of resource pools li- with the help of virtualization and dynamic scaling and management of power supply, storage, platform services are all being delivered on demand according to the user for the customer satisfaction on internet. We had seen three different layers of cloud computing. What are these? Infrastructure, platform, and applications. In cloud computing, utility computing and grid computing are the ancestors of cloud computing. Then cloud computing are of three type: public, private, and hybrid. How it has been created means created with the help of scalable hardware and scalable softwares that allowed remote computation for data storage and access using services. We had also seen cloud technologies which that the new technologies has came up. The older technologies on which new cloud computing technologies is started. So what are these? Like hypervisor virtualization, load balancing, VPN, SAN, SOA, web services, and many other technologies are behind cloud computing. So these are the technology which works with for cloud computing in backend, and these all technologies were existing since even before cloud computing was being introduced. So it is like redefining cloud computing that already with the help of already existing services or technologies, and we are just re-advertising the newer one, and it is just a hype of new technology and new campaigning for marketing purpose or for the old technologies. What are the overviews of cloud computing like? It is analogous to grid computing, electric network. Concepts are being converged for infrastructure and shared services, and minimize maximization of effectiveness of shared pools. Resources for multiple users are most important feature of cloud computing. Then resources for the dynamic reallocation as per the demand of user. Then efficiency of computing power resource like electricity and less air conditioning required, less rack space required. Then there are multiple users that can be accessed on a single machine with the help of virtualization. User can retrieve and update data flexibly for his or her application. There are difference between capex and opex. So nowadays operating expenditure are much higher as compared to the capex. So now the OPEX is like operating and managing the hardware resources, large number of hardware resources or infrastructure. So all this large size of hardware and resource infrastructure management was being done with the help of OPEX and which can be done by the cloud provider and cloud manager, so that OpEx could be optimized. Then CapEx means keep on adding hardware resources over period of time. So CapEx is more costly, means keep on adding new hardware. So now world is moving from CapEx to OpEx. This is the business requirement. Then what are the benefits of OpEx and why cloud? So the most important benefit is resource sharing, coherence of economical scaling that are required. Then avoiding upfront infrastructure cost means sudden increase of the demand of particular resource, like some file or some access to the some video. So sudden increase of that could be avoided. Then code development and infrastructure development is one of the important thing that can be avoided by taking cloud computing as our technology. So we can focus only on cloud code development instead of focusing on infrastructure. Next, we have to run faster applications and have less manageability and maintenance that will enable good IT services or IT infrastructure. So these are the benefits of using cloud computing. Next, fluctuation and unpredictability of business demand. It is required to be adjusted or maintained. So we don't know how much amount of load is about to come for accessing some particular resource on cloud. So cloud computing is important in that way. Cloud computing also works for pay as you go model, means how much a user want to use, they have to pay only that much, and charges will be done according to that amount. Then reason for the growth of cloud computing are basically high capacity of network, low cost computer, storage devices, hardware virtualizations, and service oriented architecture, utility computing. These are the reasons behind growth of cloud computing. Then vendor is experiencing high growth rate annually. This is why cloud computing are being used. History, what are the history behind this cloud word? So it's metaphor of internet. In 1950s, large scale mainframe computers were there, which were also being large size at that time. And then in 1950s also sharing of CPU resources, mainframe computer, time sharing is the concept available. So how we can say that sharing of resources was introduced by cloud computing? In 1970s also remote job entry, means remote procedure calls were there with the time sharing. So in 70s also some of the concepts were there which were used by cloud computing. Next, in 90s, VPN, virtual private network was there, telecommunication companies were there, point to point circuits, data connections were there, efficient bandwidth, big servers, network infrastructure, scientist technology working for large scale computing, for time sharing, code optimization for the infrastructure, operating system platforms online, and applications to prioritize CPU in the operating system was there. So all these features and functions were also there since 1990s, and these are being used by cloud computing. Now in 2008, Eucalyptus came up as an open source for infrastructure as a service. Then Amazon Web Service came up. Then Open Nebula came up. This improves quality of service for guaranteeing the service level agreement. And all these things are being introduced as a new term named cloud computing. In 2006, Elastic Compute Cloud came up from Amazon, then Rackspace, and there are various other projects which came up. And then After that, because of all these things, Leslie Lamport had got a Turing Award for his work on a time clock and ordering, because he is one of the pioneer behind the behind the well-known technology mm, like distributed time sharing of CPU. These are the new and novel thing that he had introduced earlier, which has got many uh, citation on his paper, and many scientists had used those his research, and that research had created impact on cloud computing as well. So the cloud computing creation of this impact resulted in really high end high end quality for cloud computing. And this is why one of the reason why ACM Turing had given him as a Turing Award winner. And this is one of the most important and important feature of distributed systems, and which resulted in cloud computing later on. So since 1978, his paper Time Clock Ordering of Distributed Systems is been working well. And currently he was a principal researcher at Microsoft, and he was also famous for latex that you see. So Turing Award, why Turing Award is been given to him? Because it is a well-defined coherence seeming chaotic behavior of distributed system in which several autonomous computers communicate with each other by passing messages. So this passing messages was the concept given by Leslie Lamport, and devising important algorithms and development of formal modeling, verification protocols, improvement of quality of real distributed systems. All these things were the most important features that we see in distributed computing, which now been turned up as cloud computing. So these are the important feature which has improved performance and reliability of computer system. And what the Google vice president says that it is like growth of a shift of large ever scale distributed system and cloud computing, which Leslie Lamport had significantly increased. Further, he had contributed on parallel and high performance computing, concurrent algorithms, reliability features. So all these things were the important, and this is important for the engineering and programming point of view. Again, the industrial growth has came up with the help of cloud computing and distributed systems, and this has also been uh, improved Bing technology of Microsoft. Bing research Bing search engine was being improved in Microsoft. These are the important thing that because of which Leslie Lamport had got ACM Turing Award. And I was lucky be to be the part of Heidelberg Laureate Forum, where he almost come in every year. So I got chance to meet him face to face. So I had done discussion with him many times. So these are the picks from the Heidelberg Laureate Forum, and I also got invited for Heidelberg Laureate Forum 2020. Earlier, these are the picks for Heidelberg Laureate Forum 2019. So Leslie Lamport. He's Leslie Lamport. We had done a one-to-one discussion with him on several topics and how he did research. These are the laureates, and he is the fundamental guy behind graph computing and graph technologies data structure. So these are the laureates like Leslie Lamport. So here in the from the left hand side behind Daffy, there's Leslie Lamport. So these are the laureates. These are the students who got selected for this event. These are the students, and he's Robert Tarzan. So these are the picks. Next, so these Leslie input always comes almost every time on on Heidelberg Laureate Forum for meeting students, bright students, for encouraging them to do research. And uh, if you want, you can see Heidelberg Laureate Forum videos as well, where he had explained that how to do research.
Algorithms I stumbled on came from a talk I heard Fred Schneider of Cornell give about hyperproperties. Now, an ordinary property is a property of a single execution. And a hyperproperty is a property involving multiple executions.
So if,
Hyperproperties were inspired by security problems.
These are
For example, one security hyperproperty requires that any two system executions that start with the same publicly visible state produce the same publicly visible behavior.
So you can always see these videos available online for Heidelberg Laureate Forum.
Math is nature's way of showing you how fuzzy your writing is. If you can't express something in math, and at end, we may turn memory and quality and reliability of software products. So in the last 20 years of my research, 15 of them spent in the employment of Microsoft.
So you can go and see those videos available for Heidelberg Laureate Forum where Leslie Lamport was there, and you can also see other laureates and get motivated from them. So next we'll see cloud computing technologies. So what are the important cloud computing technology that are there? So most important one is software as a service. What is in the software as a service? It is one of the application layer you assume right now. We'll see software as a service. We had already seen software as a service in details, and we are revising this thing. Then inexpensive storage was there. So less costly storage was there, less costly CPU usage for different purpose was there. Significant client computation could be done with the help of cloud computing. Then sophisticated client algorithms was there, which includes HTML, CSS, RESTful. Then client broadband technologies were there behind cloud computing. Service oriented architecture technologies were there for cloud computing. Large infrastructure implementation by Google, Yahoo, for real world massive large scale distributed computing. Then commercial virtualization was there, like of Amazon Web Service, Elastic Compute Cloud. Then cloud computing upgrade versions for grid computing was there. Then quality of services were provided. And then data compute intensive parallel application could work. So these are the main benefits and advantages for cloud computing. So supercomputer, grid computing, utility computing, if you go and study them, then you will see from where this cloud computing had been evolved. So pay as you go model was the feature of utility computing. Illusion of infinite resources was the feature of utility computing. Demand billing, like based on hourly basis, daily basis, and number of user was the feature of utility computing. Now people start saying utility computing as cloud computing. So software as a service is one of the layer of topmost layer of cloud computing. Hardware platform and software was there for as a service. So X as a service was next. We'll see virtualization and services. So cloud computing is the combination of these two technologies basically, and which has the combination of virtualization and services working together for providing user as a cloud environment. And because of these two things, user don't need to know much detail about these two technologies. What is virtualization? It is process of creating illusion for the physical resource which is working behind, and you just use the amount of resource that you want. So large size of machine could look like could be created a small space for you to use. Means if there is RAM of 512 GB, instead of that, if you just demand for 62 GB of RAM, so you ask for a machine with a 64 GB of RAM, then out of 512 GB of RAM, you will only get 64 GB of RAM. That is the power of virtualization, and it is useful for management and using for the user for creating some illusion of physical computing device that with the help of software for kernel based for virtualization. Next is service oriented computing. What is the SOA? It creates services as a sub problem, and these sub problems and services were integrated together to solve a bigger problem. So there are small software codes which work and exposed as a service and which can be combined together and be used by the user. And these service further divided into individual operations. And what are the operation? Basically procedures which are being exposed to the internet. So it is like a remote procedure call. Instead of remote procedure call, service oriented architecture says it as operation. So these service have operations in them. And what are the operations? These are basically procedures which can be exposed on internet for the usage by the another client machine. Next, cloud provider provides its resources in the form of services, and well established domain of SOA and virtualization being used for providing these services and resources. This will result in globalized and user-friendly technology. So the virtualization tools like VMware and Box that we see are basically for single machine laptop based system or small machines that we see was being used, and inside those VMware and VMbox virtualization soft codes were there for kernels for creating illusion of resource. Like you have 4 GB RAM laptop, you create 1 GB of Linux machine over the operating system installed for 4 GB. So you have a small laptop with 4 GB of RAM, and you install one more operating system of with 1 GB of RAM with the help of VMware and virtual box machine. The same thing would be done with the help of cloud computing virtualization thing as well for the larger server. So this server are like 512 GB, 1000 GB. So these large servers being broken into smaller images of operating system which has a small size of RAM, small size of storage, and thus it is like creating illusion. So it's similar thing like VMware and VirtualBox, but for the large size servers. And one more way of doing this virtualization was combining multiple machines. How we combine multiple machines? So combining multiple machines with the help of Hadoop, Storm, or some middleware tool which actually do distributed operating system. So these are also called as distributed file system. So there are operating system being installed like Ubuntu being installed in 5 machines, and above that, on top of that Ubuntu, Hadoop distributed file system was being installed, and they are being used and worked out, and then user will see all these 5 machine with the help of HDFS, Hadoop distributed file system, as one. So this is also one of the way for combining small machines together to see it as a large machine. So this is again illusion. So I told you about two type of illusion. One large machine was being divided into small images of operating system working for a small amount of resources like 64 GB of RAM out of 512 GB of RAM in a server. So this is one of the illusion. And again, there are 16 GB of 5 RAM, 16 GB of RAM in each machine, and there are 5 such machines. So these 5 machines could be combined together and with the help of Hadoop distributed file system for map reduce processing, then you will feel like it is 64 GB of RAM working together. So large amount of RAM you can see. This is the beauty of doing illusion of virtualization. Next, we'll see mainframe computers. So the mainframe computers are basically computing with the critical large bulk of application, means batch processing. It is old term. Then peer-to-peer computing distributed architecture came up for supplier and consumer, old technology. Then grid computing came up, means clustering different computers machine together in a network. Utility computing came up, means pay as you go model with the help of CPU and storage that a user going to use. Then service oriented computing came up with the distributed service working for one as a owner service provider and one as a user, which has interaction and flexibility and orchestration of the requirement of the demand of users. So all these things, peer to peer and mainframe, then grid computing, utility computing, SOA or software as a service, derived to cloud computing. So what we see newer one is cloud computing out of them. Then hardware and infrastructure and software that we are talking is not of 10 CPU, not of 100 CPU, but it is like thousands of CPUs working together, huge size of RAM working together in each machine. So high size of storage working together. These are the size of basic clusters available. Can we establish cloud-based things in our lab? Yes, like Eucalyptus, we can install OpenStack, we can install OpenNebula. Google App Engine is there for deployment of web application with the help of Google Web Toolkit. So we developed develop a web application with the help of Google Web Toolkit, and then we deploy our web application on Google App Engine. Hadoop we can install in our lab. Storm we can install. Service oriented computing, grid clusters we can do. Next, data center. So data center is basically facility used to house computer, and it's like associated components and telecommunication and storage things. It is one of the large size of a server which actually stores a huge amount of data. And these data center have computation intensive also, so they also require power for maintenance, and cooling environment is required. Fire alert, safety alerts also required for all these type of data centers. Various security devices are required, human security as well as firewalls type of security. Both type of securities are required for these data centers. Then large data center are industry scale operations, and it consumes very high heavy electricity like a small town. Then cloud engines are examples: Eucalyptus, OpenStack, Nimbus, OpenNebula for infrastructure as a service, basic. Then what is web services? So web services are interoperable machine to machine interaction over network with the help of WSDL and SOAP messages. So two machines communicate with the help of WSDL as an interface and SOAP message the as the content of what they want to communicate. So how they communicate? So SOAP message goes over top of HTTP that we see in the browser. So on top of that, how it goes, XML is the standard. So SOAP message and WSDL was written on XML standard language. What is WSDL? It is description of web services in XML. What is SOAP? It is like a message in XML which is added as a packet over the network. What is full form of WSDL? It is Web Service Descriptive Language. What is full form of SOAP? It is Simple Object Access Protocol, like Hypertext Transfer Protocol. Virtualization. So hypervisors are the basic fundamental technology which works for the virtualization, for creation of virtual machines. So what is the reason for doing virtualization? To create virtual machine, which is also called as images. Image has a different operating system with some software in it with different size images was there. Different size images means having 16 GB of RAM, having 64 GB of RAM, even larger 256 GB of RAM. So these are the size of RAM, and these will define basically the image size and virtual machine that we demand, we required, and we have to pay according to it. Then these are like programs like physical machine. So we have to program to look like them as a physical machine. How we can program it? We can program it with the help of hypervisors for doing abstraction of underlying physical machine. So the machine could be of 512 GB RAM, but we are doing abstraction so that user will look only 64 GB of RAM image of operating system Ubuntu. Next, hypervisor are of two types: bare metal and hosted. So what are the bare metal? That it is like on directly on the infrastructure, means hardware. We do direct direct installation of these hypervisors. And what are the example of these? Microsoft Hyper-V, Zen. So these are like hypervisors on top of operating system, and then you can load operating system on those bare metal deployments. So bare metal actually runs directly on hardware, and various operating systems like Ubuntu, Windows can work on these hypervisors. Next, hosted ones, like you have installed uh, operating system Windows. Now you want Linux also for some purpose. What you do type to hosted hypervisors or virtualization tools like VMware, VMbox available, and on that, on top of Windows, you install what? You install another operating system with a subset of hardware resources that you have, and You install Ubuntu over Windows with the help of VMware and VMbox. So example of that technology which works behind VMware or VMbox is KVM, kernel virtual machine. Then big data. Big data are of two types. Batch processing means large data set available, and there's real-time data set available. So large data set available being processed with the help of Google file system or Hadoop distributed file system. Then real-time stream processing could be done with Storm as well as Apache Spark. So Spark is also there for doing this real-time stream processing. Then this different cloud were there, like hybrid, private cloud was there, public cloud was there, and and intermediate of this means combining of private and public cloud means hybrid cloud also there, and there is community cloud also there. So what are the private cloud? Private cloud is basically organization install its own cloud at its own within its own premises and organization itself for with proper physical manual security. Then public cloud is like Google, Facebook, so we use their services directly. Hybrid cloud is like combination of private cloud, and then the resource, when there's high demand, then public cloud was being used. So these two things when combined, private and public cloud, then we get hybrid cloud. So it hybrid cloud actually enables usage of private cloud. When private cloud is overloaded, then we moved our load to the public cloud. Next, community cloud. Various different organization comes up together, like research organization like Sun Geneva, NASA, BARC in India. So all these things combined together and use some collaborative community cloud, which will result in solution for the computation intensive applications. So this is the example of community cloud. Next, public cloud. We'll see what are public cloud. It is like a pay as you go model, and these public cloud are similar to the private cloud as well, and having public feature for security, storage, and example of these are Google, Microsoft, Amazon Web Service, which operates on infrastructure data center level. And what are the services like Direct Connect, Azure? So these are the services that they provide. Then private cloud, we establish our own cloud and intelligent behavior and decision making for that cloud we do. Security, we do firewall and physical security guard that we hire. And we also need to hire some private cloud manager or technologist for space and hardware and environment control and electricity. Next, operational expense like capital expenditure. It required huge capital expenditure, and operational expenditure means manager need to be paid. Capital expenditure, number of machines we need to increase. So it is like buy build means first we have to purchase machine, then build private cloud, and then manage also. In hybrid cloud, sudden cloud busting happens at the private cloud end, so we move our load towards public cloud. This is the main feature of hybrid cloud. So hybrid cloud is like extension of capacity and capability, and integrating the private and public cloud together. So it's like if organization have some client or private cloud, but interconnected that application business intelligence. So business intelligence of public cloud could be used with the help of private cloud in an organization, like certain demand and at a small time, for a small period of time, a spike came up, and that spike, sudden spike, could be managed with the help of public cloud infrastructure. So this is like extra payment, extra computation, extra thing is also required for this. And advantage of this is the same, like payment only for the extra computation that they are required. So we need to pay for both the things, private as well as public, but we need to pay only extra amount whenever it is required. Next, this type of deployment models, like distributed cloud was there, multi cloud was there, inter cloud was there. What are distributed cloud means? Different machine at different location working together as a single machine. So these are the distributed cloud. So how these are distributed cloud works, that there is one cloud, cloud one, there's another organization with cloud 2, there's a third organization, cloud 3. So these three are being combined together and providing some large part of compute cloud that are like distributed cloud. Next, multi-cloud. Multi-cloud is like multiple vendor for the particular cloud, which can be integrated together. So the single vendor dependency on single vendor could be reduced, and multiple vendors, cloud vendors were there. So we choose and we flexibly choose and migrate from one cloud vendor to another vendor for in the case of disaster or some management. Then intercloud, what is intercloud? Means cloud of cloud. Means what is cloud of cloud? It is like interconnected network. So interconnected network, what is interconnected network? It is internet. So network of network is called internet. Similarly, cloud of cloud is called as cloud, intercloud. What it does, interoperability between public cloud, two, three, four public cloud are working together, such as hybrid cloud and multi-cloud thing could be there in the intercloud. So these three definitions are very close to each other: distributed cloud, multi-cloud, and intercloud. So all these things are overlapping on each other, different purpose, different users, and different researchers call them in a different name, like intercloud, multi-cloud, distributed cloud. All are having a huge size of overlapping. Means sometimes distributed cloud could be said as multi-cloud, sometimes multi-cloud could be said as intercloud. So each of them could be exchangeable. We'll see risk. So what are the risks involved in cloud computing? We quickly see risk: service provider management and accessing the data, accidental deliberation and alteration of some of the deletion of information could happen. So these things could be accidentally deletion of some data. Then many cloud provider shares information with the third party, and legal laws were not like this to share the client data to another third party. So sharing of such information is not good. So legal issues were there between client to accept privacy policy and start using cloud services. Then possible solution: strict auditing. So strict auditing could be there, privacy policy, legal agreement should be there, encryption of the data and then storing that data on cloud could be possible. So the encrypted data could be put on the cloud and then retrieved from the cloud, and that the cloud provider could not able to read that data. Then legal ownership of data is also confusing, that organization who is providing cloud is the owner of that data or the user who put the data over there, and the user who developed the data. So this is one of the confusion. Then many terms of service level agreement could be done for the ownership of that data. Suppose if some YouTube video provider is there and he developed some YouTube video over on YouTube channel. Then after that, the that YouTube channel owner was lost password of his YouTube account or Gmail or everything. So he said that okay, that video is not of much use. So he forgotten all the things about the channel and he start doing some other work, some other profession. So that videos will be actually being owned by YouTube, because there's nothing that the cloud YouTube channel user could able to do. So these are the things cases happens. Next, cloud privacy, like physical control on private cloud is more as compared to the public cloud. So private cloud physical security is more as compared to the private cloud. Then public service, cloud service makes secure building. So public cloud like Google and Facebook has a huge size of building and they have a huge size of security available with them as compared to the small organizations. Then naive users do not understand and read terms and condition and accept the agreement. So there are many agreement which came up and they said okay, accept it, and naive user go into the trap of that terms and condition. So this is one of the privacy concern. Next, private cloud is normally secure, means private cloud has a physical security that you can provide, but in the case of public cloud, upfront cost could be reduced, means huge size of number of users are coming for using that application, that could be reduced, and with less time to start, means public cloud could be hired and start within quick, means in 1 day or 2 day with just legal agreement, and then putting the data on the public cloud. Next we'll see cloud service in next class. Okay, thanks all of you.